In my last video, I went through how I was trying to build an updated version of my InfoPanel project. It was built around a touch screen rather than using physical buttons to drive the device, and I wanted to run all the software on a Raspberry Pi Zero 2W. However, I found that when I installed the operating system on there, I couldn't even start up a browser, so I couldn't really get anything to work. Let's go and fix it. Hello once again, Pi geeks and techno nerds all around the world. My name's Jeff, and I'm an IT professional who's been in the industry for over 30 years. I've been using Raspberry Pi since they first came out, and I wanted to share with you some of the projects that I've done along the way. If you like what you see on this channel, please hit that thumbs up button, subscribe if you want to see more, and hit that notification bell so you can be told when I put a new video out. Let me know in the comments how you get on with this project, and if you've got any ideas for projects that you'd like to see me do in the future, put those in there as well. Before we go looking at solutions, let's go and take a look at the problem I'm facing first. Here you can see the actual hardware that I've got put together. Here is the Raspberry Pi Zero 2W, here is the monitor controller board, and that's connected just via a USB-C cable to micro USB. For the pictures, there's an HDMI connector on the monitor controller board connected to the micro HDMI socket of the Raspberry Pi. There's then a cable connecting the monitor controller board through this little hole in the backing board through to the touchscreen. The touchscreen itself is then mounted inside a picture frame, so everything looks really nice. So now let me show you what happens when I try to run Raspberry Pi OS on my Raspberry Pi Zero 2W. So here I have Raspberry Pi OS Bookworm running. This is the 64-bit version, and that should run just fine on a Raspberry Pi Zero 2W. You can see the box has started up okay, and I can move the mouse pointer around. And with this box that's showing up here about an SSH issue, I can cancel that just by bringing the mouse pointer down to the OK button and clicking it. And that clears that box away. However, look at what happens when I try to start up a browser. Firstly, it brings up this box here, saying that Chrome needs at least 1 GB of RAM in order to run. Now the Raspberry Pi Zero 2W only has 512 megabytes installed and you can't expand it. So this is an issue, but there's a button there to launch the browser anyway. Let's see what happens when we do that.
2 very boring minutes later.
And the browser's finally started up. But what I found here is if I actually try to navigate to a web page, it just takes forever. So really, this is just entirely unusable. Now I've also tried to use the 32-bit version of Raspberry Pi OS Bookworm, and I encountered exactly the same problem because the same version of Chrome is used in there, and that is also asking for at least 1 GB of memory. However, there is an alternative. In Raspberry Pi Imager here, if we click on Choose Device and select our Raspberry Pi Zero 2W, and then click Choose OS, there's an option here to use Raspberry Pi OS Legacy 32-bit, and this is a port of the prior version, which is based around Debian Bullseye. And I found this actually works a lot better. I'll go and write this to an SD card, and then reboot my Raspberry Pi from that. So here we are now with Raspberry Pi OS Bullseye up and running. The touchscreen is working just as well, and I can clear this window just by clicking on the OK button. But what's better here is if I go to start the browser, it actually starts up reasonably quickly.
30 seconds later.
Or at least quicker than what it did in the Bookworm operating system. Generally speaking, it's using up less resource, but it is still taking up an awful lot of memory. If I connect to a terminal here, and then I run htop, you can see that around half the memory of the Raspberry Pi is already being used, and we haven't even navigated to a website yet. Now here I started up the Chromium browser and put in the URL for my info panel. Now believe it or not, this is 15 minutes later, and you can see it's hardly loaded a thing. Switching over to htop, initially the memory usage doesn't actually look that bad, 270 megabytes out of 427. However, there's a lot of memory that's allocated to buffers and cache, and so actually the memory is entirely being filled. And so the system is now swapping like crazy. You can see 310 megabytes of swap file have been used at this point. And the load average on the box is huge at 9.5 or thereabouts. For a Raspberry Pi 02W, this should never exceed 4, or it shows that the box is severely overloaded. So using Chromium on the 32-bit version of Raspberry Pi OS Bullseye is just a non-starter. But there are actually some other options. Epiphany is a lightweight browser that's based upon the WebGTK toolkit. Equally, there's another one called Midori, built on the same framework. Now, I prefer Epiphany over Midori purely because, as you can see here, Midori hasn't been maintained in over 6 years, whereas Epiphany's codebase has been updated in the last few weeks. The other thing that I have here that's actually occupying a fair amount of memory is the desktop itself. Now, even though Raspberry Pi OS actually uses quite a lightweight window manager, it contains a whole lot of stuff that we don't actually need. I don't need a start button up in the corner here. I don't need a menu system. I really don't need much at all. All I need is a browser to run. And there's another window manager that I can use for that. The Matchbox window manager basically allows you to run a plain X Windows system with kind of nothing running on it. You can just specify an application or applications that you wish to run on top of it. So in my case, I can start this up as the window manager and then just start the Epiphany browser. Now, doing all of this probably sounds horrendously complicated, but it's really not. I've wrapped all of this up into a very simple installer. So let's go and take a look at that. Back in our terminal session here, I'm just going to pull all of my source code for this out of GitHub. And I can do that with this command here, git clone -b touchscreen support. This is the branch that I have in my code that's got the code base for all the touchscreen support. https://github.com/jeffspieinthe/infopanel.git. Now that's done, I've just moved into the InfoPanel directory that it created. You can see I've got a subdirectory in here called pits-infopanel and another README file. The README is just what you see if you go to the GitHub page, and that just contains all of these instructions for how to build and run the software. But this is really simple. I've wrapped all of this up into a Debian package, and all we have to do is build it. And you can do that with this command here, dpkg-deb -b pits-infopanel. And that builds the package. Now, before I install it, I want to make sure the package has got all its version numbering correct. So I'm just going to rename it using this command here, dpkg-name pits-infopanel.deb. This will actually use all of the metadata within the package in order to rename the file. And so that's renamed it to pits-infopanel_2.0.0_armhf.deb. Now the armhf part here is really important. This means it's a 32-bit package for an ARM platform. And that's the exact platform we're running here. We're using the Bullseye release of Raspberry Pi OS and the 32-bit version. But now we can just install the software. And we can do that with sudo apt-install/pits-infopanel_2.0.0_armhf.deb. Here we just need to confirm that we do want to do the install. Now this has not only installed Matchbox Window Manager and our Epiphany browser, but it's also set up all of the software for the InfoPanel project. Now I went through a code walkthrough of all of that software in the last video, so I won't repeat myself here. But if you want to know all of the details of the software, it's all in that last video, and there are chapter links so you can get through to the section that you want. But now everything's installed, all I've got to do is reboot. And there you can see that everything has started up successfully. And the status section and the news section are both dynamically updating. If I click the touch buttons, they do work, but the response is really pretty sluggish. But it's really not bad. everything's behaving really pretty well. Looking at HTOP here, you can see the CPU is fairly well under control. The memory usage is still relatively high at 265 megabytes. However, compared to what Chrome would be consuming at this point, that's a real win. Now, the only real downside of the Epiphany browser is that it is based on this WebGTK toolkit, and that is pretty memory hungry in itself. And it also seems to consume a bit more memory over time. And I do frequently see the box actually starting to use the swap file. You can see it's used about 168 megabits so far. That seems to grow over time. So we need to carefully control the swap space. But one of my viewers actually really helped me out with this. This is a comment that I received from someone identifying as someone, and they suggested using a technology called ZRam or ZRam. Now this is just a swap file technology, but what it does is any data that gets pushed into the swap memory actually gets compressed as it gets pushed in, and then it gets decompressed as it gets pulled out. So you end up with very efficient use of your swap memory. And what I've found is that I'm not actually running out of swap at all. I've configured my system here with 1 gigabyte of ZRAM memory, and setting that up is really simple. Now my InfoPanel package installer will install the ZRAM tools package that you need to use ZRAM in the first place. However, just for this purpose here, I've uninstalled it again just so I can show you that installation process if you ever needed to use it on a different system. To install it, you just use the command sudo apt install zram-tools. And then you can configure it using the command sudo vi, or if you'd rather use nano, please go ahead, /etc/default/zram swap. In the config file, if you just come down to where it says size, uncomment it, and then change the value here to whatever amount of extra ZRAM space you want, in this case 1 gigabyte, save the file, and then quite simply reboot. Once your Raspberry Pi is rebooted, if you run the command lsblk, there will now be a new device listed called ZRAM0, and you'll see in this case I've got 1 gigabyte of space. If I run HTOP now, you can see here that it's saying I've got 1.5 gigabytes of swap space available. 1 gigabyte of that will be the ZRAM swap, and the remaining 500K is what I've got configured as normal Raspberry Pi swap space. Now before this project, I'd never used ZRAM before, and so I'm really grateful to someone for mentioning it to me and suggesting it. It's a really great way of efficiently managing your swap space. And now we're nearly there. Everything's running really pretty well. But there is one thing that I want to clean up in the software, just to make everything look and work a little bit better. So switching back to the actual panel here, you can see it is all working very nicely. If I hit one of the buttons here, for instance to go forward in the calendar, that responds pretty well. And equally I can hit the refresh button to refresh the whole display. But I was getting really annoyed at how the status section and the news section completely blank out when they refresh, as you could see just there. So I've made a couple of changes in the software to improve this. Switching over to the code, you may remember from the last video's code walkthrough that I actually had 4 templates in this template section. I also had ones called status.html and news.html. Well, those blocks I've now pulled into the main index.html, and those are shown just here. For each, I've just created a static div element that is ultimately going to contain all of our status information and news information. But you can see here, these are no longer being rendered using the Flask application. Instead, the Flask template is just rendering these placeholders. Within the infopanel.py code, I've introduced 2 new routes. one called /VPN data, one called /news data. For the function to get the status information, it just calls the pre-existing functions to actually get the data and build it. However, once it's got the list of all of the status information, it just transforms that into a JSON structure using the built-in JSON.dumps function. This will just take any arbitrary object and construct a JSON representation of it. I then just return that data, ensuring that I set the MIME type, or the type of data being returned from the call, to application/JSON. This way, the JavaScript that calls this will be able to recognize that it's getting JSON data back. The /news data route works in exactly the same way. It calls the pre-existing getNewsList function to get the data, transforms that into JSON, and then returns that JSON data back to the caller. Flipping over to the base.html template, I've added some new JavaScript functions in here. This is the function to render the status data. Firstly, it uses the jQuery getJSON call, and this sends the request off to the /VPN data route. When that call completes, it takes the list of status items that are returned, and it just dynamically builds some HTML containing that data. Once all of that HTML is built, it then just stuffs that HTML into the div element that I mentioned in the index.html template. This getNewsData function works in exactly the same way, using jQuery to send a request to the news data route, iterating over the resultant data to create the HTML containing all of the rendered news stories, and then setting that HTML that it ends up with as the contents of the div element that I pointed out earlier. As a result of this, I've updated the calls to set interval, so they just call these functions. And it's had quite a profound effect on the UI. I'll get this new version installed on the panel so you can see the end result. Okay, so here we have the panel running again, and you'll see that everything now looks a lot more stable. And just there, you probably saw the status section of the panel updating in real time, but it didn't do that horrible blanking when it refreshed the data. Instead, everything just updated dynamically, and it looked a lot cleaner. And so here, I'm really happy with this end result for the panel. It looks pretty good, it works well, and although the touchscreen can sometimes get a little bit unresponsive purely because the system can be swapping quite heavily occasionally, I'm more than willing to live with that. So I'm very happy with the end result. Now, there is, technically speaking, one more optimization you could make to this panel to make it a little bit more responsive and a little bit better with the way it manages memory. I'm going to install a tool here called HDPalm. This is a tool that can be used to test the read speed from your hard drives. Now here I'm working from an SD card. It's quite a good one, but it's still an SD card. And I can test the read speed of it, or at least get an approximation using this command here. Sudo hdpalm -t --direct, and then the name of the SD card device, in this case /dev/mmcblk0. And in this case, it's giving me, roughly speaking, 20 megabytes a second. So this would be around 160 megabits a second. And that's really not very good. One way that this could be improved would be by using either a USB stick or an external SSD connected via USB to the Raspberry Pi. Now, the USB port on a Raspberry Pi 02W is only a USB 2 port, and as such, it's got a theoretical maximum of 480 megabits per second of transfer speed. Now, on a Pi 02W, you're extremely unlikely to ever hit that. The best I've ever got is around 300 megabits per second. I've never seen anything be able to go above that. However, if I went down this route, I'd then need to buy a MicroSD to USB hub, the USB drive itself, or an SSD, and an enclosure to house it. And for me, given what I'm trying to achieve with this project, which predominantly is just to have a panel that shows me information, it doesn't actually bother me that much that sometimes the buttons can get a little bit unresponsive. So I'm not going to be doing that, but I just thought I'd point out that there is another way to speed up the system just a little bit. And especially if you're doing some other kind of project with a Pi 02W, that might be really useful. Now, of course, the last way that you could make all of this run a lot quicker is rather than using a Raspberry Pi 02W, you could use a Raspberry Pi 4 or a Raspberry Pi 5. However, for something like an information panel, that feels severely overkill to me. And it's really a waste of resources. The Pi 4 and the Pi 5 are fairly powerful single board computers. And so I feel it would just be quite a waste of resource to use them for this. But again, that is entirely up to you and a reflection of what you want to do with your info panel. So please don't feel constrained in any way by the hardware that I was using for this project. Use whatever is correct for your implementation. But now I have my information panel, I'm going to go and hang that on the wall. And so that's it for this video. If you like what you've seen here, please hit that thumbs up button. Subscribe if you want to see more, and hit that notification bell so you can be told when I put a new video out. Let me know in the comments how you get on with this project if you give it a go. And if you've got any idea for other projects you'd like to see me do in the future, let me know in there as well. Also, if you've got any other ways that you would go about optimizing anything running on any kind of Raspberry Pi, comments about that sort of thing are always welcome. Thanks so much for watching till the end, and until next time, bye for now.